Power generation is a critical requirement on board ships. Even a brief blackout can lead to severe consequences, such as grounding or collision, posing significant risks to the ship and its crew and causing substantial losses. A ship relies on multiple generators or auxiliary engines to ensure a continuous power supply. Ship engineers are responsible for monitoring and maintaining these power-generating units. To optimize efficiency, a skilled ship engineer aims to run the minimum number of generators while achieving the maximum load. This not only maintains the health of the auxiliary engines but also reduces overall fuel consumption and harmful emissions. Achieving this relies on maintaining the auxiliary engine's rated output within appropriate parameters, such as temperature and pressure. However, when the engine's performance begins to deteriorate, it results in reduced output, with high exhaust temperatures and low peak pressure. To compensate for the decreased output of one generator, another generator must run in parallel to meet the power demand. In this article, we will explore 20 possible causes that can lead to reduced power output and performance of an auxiliary engine on board a ship. Low fuel oil pressure. The fuel oil pressure drops below the required level, often due to a faulty fuel oil pump or excessively low fuel oil viscosity. Type of fuel burned. Changing the fuel grade from HFO to MDO, MGO, LSFO can lead to a decrease in engine performance and a drop in fuel oil pressure. Fuel leakage. Worn-out fuel pump parts, such as plunger and barrels, can cause fuel leakage, resulting in reduced fuel pressure at the discharge point. Fuel temperature. Inadmissibly high fuel temperatures, greater than 60 degrees Celsius, reduce fuel viscosity, negatively impacting fuel pressure. Firing pressure difference. Significant variations in firing pressure between individual cylinders lead to an overall reduction in engine output. Blocked filter. Dirty or blocked line filters in the fuel oil system can reduce oil pressure and overall engine performance. Incorrect valve clearance. Improper clearance between intake, exhaust valves and the guides can cause combustion mixture leakage, leading to reduced engine performance.
Damaged exhaust valve. A damaged exhaust valve or seat can result in improper sealing and blow-by of exhaust gases during combustion, increasing exhaust temperature and reducing engine output. High exhaust back pressure. Flaws in exhaust piping installation or fouling in the silencer can cause high exhaust gas pressure and increased exhaust temperature in all units. Contaminated passages. A contaminated exhaust manifold can obstruct exhaust gas flow, leading to increased exhaust temperature. Insufficient fresh air supply. Adequate fresh air supply is crucial for efficient combustion. Reduced scavenger supply results in incomplete combustion and reduced engine output. High suction air temperature to TC, operating in hot regions, for example, near the equator or Gulf regions during summers, can cause higher atmospheric air temperatures entering the TC compressor. Insufficient cooling can decrease engine performance. Low charge air pressure. Inadequate scavenger pressure results in insufficient air supply to the cylinders, leading to incomplete combustion. Incorrect charge air temperature. Incorrect cooler controller settings can lead to excessively high or low output air temperatures supplied to the engine, negatively affecting combustion efficiency. Contaminated charge air cooler. A dirty charge air cooler restricts seawater's cooling efficiency, resulting in increased exhaust temperature. High cooling water temperature. Elevated seawater temperature leads to warmer air being supplied to the air cooler, causing high exhaust temperatures. Air cooler cooling water bypass. An excessively open cooling water bypass valve in air coolers leads to higher air temperatures supplied to the engine. Worn/damaged turbocharger components. Fouled or damaged parts of the turbocharger, such as blower, turbine, or nozzle ring, can impede exhaust gas flow or reduce fresh air supply, resulting in a sudden engine output reduction. Scavenge air leakage. Leaks in the scavenge air inlet pipe to the cylinder reduce air supply, leading to incomplete combustion. Incorrect tappet clearance setting. Improper tappet clearance allows inlet/exhaust valves to open more or less than required, causing inappropriate combustion or early escape of the combustion mixture.